Hello student, in this video we will study about the chapter number 8, which is a basic concept of chemical bonding. And basically in this chapter we will study about how the atoms are bonded to each other to make a compound. And there are mainly three types of compounds are there: ionic bonding, covalent bonding and metallic bonding. So we are not going to study about the metallic bonding, but mostly we will study about ionic bonding and covalent bonding, and then Lewis symbol, and then what is the octet rule, and then bond polarity, electronegativity, how to draw the Lewis structure, resonance, exception of the some octet rule, and strength and length of the covalent bond. So first we will start the what are the types of the chemical bondings are there. So there are three types of chemical bonds. Number one is called ionic bonding bond, number two is covalent bond, and third is metallic bond. So we have studied these in previous chapter about the ionic compound and covalent compound. So how the ionic compounds form: associated with the ionic compounds, electrons are transferred. So ionic compound, if you remember, they are formed between the metals and non-metals. When a metal combine with the non-metal, they form the ionic compound. And what they do to form a bond, basically they transfer their electron to each other. So mostly electrons are transferred from the electron metals to non-metal. That is the main rule for ionic bond formation. Number second is covalent bond. So covalent bond is associated with the molecular compound. So whatever the molecular compounds are there, they are formed between the two non-metals, and they are formed by the sharing of the electron. So here is electron transfer, here is the electron sharing. And number three is metallic bond. So metallic bond is associated with the pure metal. So in this picture, this shows that this spoon of metal which have the metallic bond contain salt, which is sodium chloride. So sodium is a metal and chloride ion is a non-metal, so they are forming ionic compound. When we add in the water or in any organic solvent, so water is also a covalent bond, which shows these through hydrogen and oxygen, so they are bonded to each other. So in this picture you can see all three bonds are there: ionic bond between the sodium and chloride ions form sodium chloride, and covalent bond between the hydrogen and oxygen to form water molecule, and metallic bond in the steel. So these were the types of bonding, and we will start first from ionic bonds. So ionic bonding is a result from the electrostatic attraction between the positive and negative ions. So in ionic bond, always usually there is a positive ion and another is negative ion. So they share their the ions are transferred from the so ions are formed from the transfer of one or more electrons, and metal tend to lose their electron to form the cation or positive ion, and non-metal except earth A group, which is most stable inert gases, tend to gain electron from the anion, negative ion. So metals which are on the left hand side of the periodic table, they have tendency to lose the electron to make the positive ion. So always metal loses the electron to make positive ion plus E minus, and non-metals, this non-metal, gain the electron minus 1 to become non-metal negative ion, which are called anions. So these were the ionic compound, ionic bonding, and they are held to each other by the electrostatic attraction. This is the main thing how the ions attract to each other, which is electrostatic attraction. So main thing is this about the ionic bond, that where the electrons, so ionic bond is formed between by the transfer of electrons. So the question is where does the electron is lost by the metal goes, and where the electron that is gained by the non-metal come from. So it's very simple, just whenever then sodium, this is sodium and chloride ion, form sodium ion and chloride ion. This is shows that sodium metal, sodium element or atom, and this one dot shows the valence electron, which is 11th electron, and chlorine has outermost 7 electron. By the it represent by 7 dots, 1 2 3 4 5 6 7. So sodium gave or just transfer 1 electron to the chlorine atom, and it forms sodium ion and chloride ion. So here this picture shows that when a sodium metal is added into chlorine gas, the reaction is very exothermic, and these ions are formed, and at the end they form the sodium chloride. So this is the ionic compound, and here you can see this sodium and chlorine, they are surrounded by some dots. So this kind of symbol is called the Lewis symbol, and we will study about the Lewis symbol, how and what is the Lewis symbol and how to use this one. So Lewis electron-dot symbol. G.N. Lewis pioneered the use of chemical symbol surrounded with the dot to symbolize the valence electron around an atom. So any atom which have extra dots around it, so that represent the valence electrons. Valence electrons are used as a dot around the atom, and that is symbolized Lewis symbol. So it utilizes the octet rule, which can be summarized as, so Lewis structure utilizes the octet rule to form the octet, means like oct means 8. So 8 rule. What is the meaning of 8 rule? Atoms tend to gain or lose or share the electron until they are surrounded by 8 electrons, 8 valence electron, except hydrogen. So any atom, when it transfer 1 electron or gain an electron to form a octet rule, then it's called the form 8 electron around it, so that is called the octet rule. We'll see some example here, then you can understand better. So you can see in this table, this shows the Lewis symbol for each element. For lithium, it has atomic number 3, so 1s2, 2s2 and 2s 1s2 and 2s1. So rather than 1s2, it is using as a core electronic configuration, so 2s1. So the last electron is represented like this one, lithium, and 1 dot means it is a Lewis symbol. For beryllium, the last or valence shell electrons are there are 2, so beryllium plus 2 dot. Likewise boron, carbon, up to neon, they have boron have 3 dots, carbon have 4 dots. So these are the 4 extra dots are representing these 2s2 and 2p electrons. So they are valence electron. So in Lewis symbol, so if we have to write Lewis symbol for any element, what we have to do, we have to write the element, and then we have to write the electronic configuration to find out the valence shell and how many valence electrons are there, and we have to add that many dots in the form of valence electron. So sodium has 11, so last electron is only 1, 3s1, so sodium plus 1 dot. Magnesium has 12, magnesium plus 12 dot, like that. So these are the symbols of the Lewis structure or Lewis dot structure. So let's come back on our ionic bonding. So in ionic bonding, one element readily give up an electron which have low ionization energy. Usually metals have low ionization energy and they loses the electron very easily. Another element readily gain an electron has a high electron affinity. So non-metals have very high electron affinity, that is why they have tendency to gain the electron. So you can see this structure is shows Lewis dot structure, shows valence electron, and so it gave one electron to the chlorine atom. Why it gave? Because of the octet rule. You can see the chlorine has right now 7 dots, 1 2 3 4 5 6 7. So once it will take one more electron from the sodium, its octet rule will complete. So that is why this become stable. And chlorine and sodium have 11 electrons. So you can see 1s2, 2s2, 2p6 and 3s1. So once sodium will lose its valence electron, so outermost cell will have 8 electron, 2s2 and 2p6. So that is why sodium also want to maintain octet rule by transferring one electron to chlorine atom. So what happened here? How many valence electron does sodium has? 1. And how many valence electron does the chlorine have? 7. So sodium gave its electron to the chlorine atom, and then chlorine become as a chloride ion and sodium become a sodium ion. So this now chloride ion is satisfied by the octet rule, and sodium ion is also satisfied by octet rule. So this was about the ionic compound and Lewis dot symbol, and when next video we will study about the properties of ionic substances.